I'm Adam Dymitruk. I'm from Vancouver, Canada. Although originally I am from Europe. I was born in Poland, in Krakow, in the 70s, a long time ago. We emigrated in the early 80s to Canada. That's why I don't have a Polish accent anymore. Pretty much consider myself a Vancouver native. Because I escaped the communist times of Poland, I was quite enamored with all the nice things here, and one of those was computers. And very quickly, in 1983, my parents were nice enough to save up for a home computer, which is a novelty back then. I was lucky enough to get a Commodore 64 and start programming right away. Since I didn't get a disk drive, I just got the Commodore 64. So I was typing in my programs and writing them on paper, because when I turned off the computer, the programs went away. So I learned how to type very fast at an early age because I had to retype everything when I got home from school and then add more to the program. So I had iterative programming experience as well from an early age, because I had to iterate every single day on the same concept, which was interesting. I guess a year later, my parents were nice enough to get me a Christmas gift of getting a diskette drive. I was still in front of the TV, of course, because that was also expensive. So you had to plug in your computer to your television in the living room. So I had to compete for television time with my brother and the rest of the family. That made me a night owl. So that's where I got the next skill in programming, is to stay up at night and still be productive. So eventually I did get, next year, I think I got a monitor so I could have the computer in my room finally. So by 1985 or something like that, I was able to program. Anyway, I don't want to give you my life story, but it's kind of fun because it's humble beginnings. And I loved programming so much that I put up with this stuff that most others wouldn't. And by 1987, I got the reference guide for machine language on the computer and started programming low-level stuff. And then eventually, when I was in high school, I was one of the folks that had Amigas. If people are old enough, the Amiga was an incredible computer that had colors and sound that no other computers had. And that assembler was 6800 Motorola chipset. And that was fun. That started me with sort of bash-like scripting and AREX, which is an old language, obviously C, and then in college I got into C++ and Pascal and all these other languages, circuit design. And so by the time I finished high school, I was already consulting, and it was second nature because I grew up with computers. When I got into the enterprise consulting world, when I got a real job, quote unquote, when I was about done with college and all that, and was looking for higher pay, I ended up in the office environment. And this was your typical Dilbert cartoon every day. So pointy-haired bosses and managers that didn't know how to program, but really knew how to tell you what to do. And a lot of waste, and I really didn't like. It's the first time I didn't like programming, because it was more about the office environment. I did enjoy the collaboration. I enjoyed having lots of friends that were at work that also programmed, and to be able to not just go on bulletin board services to talk about programming, but to be in an environment with a lot of other people programming. So that was good. But the challenges technical challenges weren't exciting. There was VB3 and drag and drop development of controls. And I was just astounded as to what people got paid for what kind of work. I was just in awe, because I was working on much harder problems for very little money before. Now I'm making good money because I'm in an office environment, enterprise software development, but I'm feeling brain dead for not using my technical skills. And then I met a I guess, Greg Young in 2008, longer into my career. So around 2000, I was really frustrated with doing that. And I was looking for, what's the industry doing to make this a more interesting way, or a more engineering-like way to do things. And so I stumbled into the newest ways of doing things, because in the 90s, it seems it was cowboy coding. People were copy pasting code, not from Stack Overflow. That didn't exist, but there, it was really trashy code. There was no discipline. People were using whatever newer frameworks, mostly JavaScript or Java frameworks or .NET frameworks, were all going through their own iterations already, and so people didn't have very good ways of developing. And in 2008, I met, after trying Agile for a while, I was going okay. There was at least some guidance, so that everyone was doing the same thing every day, which was better. But in 2008, I met Greg Young, which said, this is how you think about information systems, about them being a series of events. It really turned a light on in my head, and it was a fundamental shift in thinking about how to think about what we're doing with computers most days. And it wasn't kids in front of a Commodore 64 figuring out assembler. It was about moving information from left to right, and storing, being accountable for what the system did. So it really showed me that your true skill set in order to make an information system reliable is not computer science skills, it's accounting skills, so that you understand how you got into a situation. So this fundamental shift in my mind of like, be more like an accountant than a computer programmer, and you'll have fewer problems. And sure enough, over the next, since 2008, now 13 years, I can say that I love programming again, because it's, I'm not solving stupid problems. I mean, they will exist. You'll have to use a new framework for JavaScript, and there's going to be corner cases, edge cases of things you just don't do the same way as you did last year or the year before. You're going to have to dig through Stack Overflow and wait for maybe get frustrated with an upgrade from version 4 to version 5 of something. That's normal. But the fundamental concept of how do I make sure I understand that I'm not chasing rabbit holes, I'm not going too deep onto different things, I'm not gold plating, etc. This accounting way of thinking about systems was fundamentally the differentiator. And so I started doing this in 2008 every day, and then starting to make event-driven systems only as a way to pursue a better understanding of the domains of different businesses, from insurance to banking to point of sale systems, inventory systems, everything that you kind of get a job in the industry. So 99% of the software that's written out there is moving information. And so I started to apply event-driven thinking, event sourcing specifically, storing every event and using that as a source of truth as a fundamental way to improve these businesses. But I got frustrated as well, because it seems no one was doing this in the industry. So again, I'm an outlier trying to move things forward. And so as a single person in a company, you're frustrated to move everyone with you. You're dragging by yourself the entire company, and there you have managers that don't care. You have regular developers that are maybe want to retire in 5 years, and they're not interested in changing anything. So this wasn't very productive, being single consultant in a place where you're some people believed in what you did and they supported you, of course. But it was very frustrating to have to do 12 jobs at the same time, or do shadow ops, as they call it, where you're doing whatever you need to do because the company is a certain way during the day, your first 8 hours. And then whatever you wanted to do for the improvements, you're doing in the evening on your own spare time, which is not very nice. And so trying to do your job was a 16-hour ordeal. Then you'd bring all your problems to meetups and discuss with people and all of this. So in 2015, I incorporated a company that basically was a collection of like-minded people that wanted to do event sourcing, understood that event-driven architectures are the way to do things. Concepts like domain-driven design better be enabled by your everyday practices, unit of work, all of this accounting stuff I'm talking about. That's all great stuff. Proper source code management, obviously, all of these things where we agreed, yes, we're all doing the same thing in different companies, and we're all frustrated because of the same problem. We don't have a team to work with. We're always trying to make a team or recruit a team as we get into these places. So that was good. Now we had a team of 4 or 5 people that could, by the time next year rolled around, in a year we became, from me working in my basement and hiring 1 CTO, next year we had 5, 6 people. We were doing projects together where we could take on an entire service or an entire solution for a company and implement it and have all the benefits. Then we got into the next problem, which is, how do you hand this off? How do you interface with the non-programming folks? How do you gather requirements that are different than use cases and user stories, etc.? Because we still have to do all of the non-technical things, and those are traditional things like Jira and stand-ups, all the agile stuff, and it just felt very expensive to do. A lot of meetings, a lot of Jira ticket writing, but there's some simplicity in the event-driven approach that we're going to get into that didn't fit the way we gather requirements, the way we track progress, the way we do retrospectives, the way that we estimate, which is a big one. How do we estimate the size of projects? Those are all different. And luckily, we were always not given the biggest budget to do these things. So we were forced to find ways to get the same things done with fewer resources. That means maybe we didn't have time to write all the user stories. Maybe we didn't have time to have all the retrospective meetings for this new format and bring up all of the things about the different infrastructure used for event-driven systems. So this is why we're here. That's at the end of that long journey. Event modeling really became a replacement for the things we didn't have time to do. So if you're going to replace things that are standard in the industry, they better do a good job. And because we had limited time and limited resources, instead of doing 10 practices of all sorts of meetings and UML diagrams or whatever else you need to prepare your solution, we only really had time to do 1. We didn't notice that we were doing that, though. This is looking back. Hindsight is 20/20. Looking back, that's what ended up happening. We ended up getting a way to get more done with less time spent in meetings, with less time producing 50 documents. We had only a small time for a limited amount of time for getting all of those things done. So we started looking at things like event storming, etc. And we kind of started with event storming. We liked the events. And in fact, before event storming even happened, when I was working across the street from Greg Young, he was working for a trading company. He started working on these requirements for event-driven systems by just putting sticky notes on the whiteboard of saying, in this trading system, there is a condition that got that made itself apparent, like there's a large institutional buy order for a certain security that appeared. So that's an event. So therefore, our system ended up putting these small orders on the opposite side to start buying up the security. And so he'd put those stickies on. So there's a timeline that he put in, and he put events on that timeline to describe how the system would work in certain market conditions to make this trading system profitable. And he would use this both for describing to the technical side as to how to write this software. But more importantly, he was able to bring the business folks on there and show them in plain language what the system was doing in each scenario to make money, so they could sign off on it and understand what the system was doing. And that was the start of event modeling, really. If I look back, I had no clue that I'd be doing this 13 years later. Like I said, this came about naturally from the pain of writing event-driven systems in real life. So, but that clue was interesting, because what he was doing was he was doing domain-driven design, finding a bridge between tech and business to understand, to show how the system works. And that's the small beginnings of a blueprint for what the company was doing in this system. It was a series of stories of all the scenarios of what the system could do. And if you could walk people through those stories of those events that happened here and these given when then things that there's a lot of good things that happen in Agile. One of those is specifications by example, where you have a given situation and then you do some action and then you test the result, right? So it's a setup, and you do your experiment, and then you take your measurements and find out what happened. And we have different words for this in the industry. So in programming, we use given when then, and before that we used arrange, act, assert, maybe from the testing side. But we also have these things in the UI UX folks, the designers. They use a situation, motivation, value. It's all the same thing, just different words in different areas. And that's another clue, is that we have these silos when we develop projects that have their own lingo and they're doing the exact same things. So why not have more of a blueprint? So going from that small old timeline of events and given when then scenarios. So for example, even back in 2008, because specification by example was there and it fit really, really well to the event-driven approach. So you could say, well, what's my given? What's my situation? Instead of just saying the system is in this state, we can say this is the previous part of the story. So we can say from left to right, I guess on your screen might be this way. From left to right, we have all of the events, such as I signed up, I registered for this product, and then I enabled it. So when I press this button, I get this result. So in other words, if I buy my shares, then the last thing that I'm testing is that I have an event for shares purchased. Those given when then scenarios were easy to do with sticky notes. And that was really good, because now you have things that will end up as actual unit tests. So you start to have real parallel workflow here. The nice thing also is that it started to decouple all of the infrastructure and frameworks, because those would stay the same as you're getting more and more scenarios. So as you talked more about the system, you'd just have more given when thens, you'd have more stories written in events, and it didn't really require any new infrastructure, because you started to get into repeatable patterns. And event sourcing made it quite dumb. Actually, event sourcing is way easier than other approaches, because there's very few patterns that you can put on top of just a single growing ledger of events. So it's really about baby duck syndrome, people that don't know about event sourcing, that makes it hard for them. They just have to learn a new way of thinking that has the appearance of being more difficult because they're learning. But I can tell you after 13 years, it's much simpler to do things with event sourcing, simply because you're not designing a large or maintaining a large schema underneath to make sure things are working together. Your most responsible thing is just to, hey, something happened, store an event to record that it happened. It can't get simpler than that. So conceptually, event sourcing is a lot more simple. You push off the repercussions of recording what you did later, and that's done more easily by having multiple projections from those events into different sets of tables or object graphs that you need for different purposes. And that kind of gets into CQRS and why you have multiple models on the read side. So once you get used to doing that as your default approach, it actually becomes a lot easier than what it used to be. And further on in your experience, you'll learn how all of the new frameworks that you're using out there where they don't use event sourcing or CQRS, although some are adopting those, like in React, you have Flux and those types of things, where you do have some similar event-like kind of pathways. But anyway, you'll learn how to adopt Next.js and any other types of frameworks on the back end, etc. How do they fit in to, working with this? But this workshop is not about event sourcing or particular infrastructure concerns. It's about event modeling, which brings those concepts as a way to collaborate together with everyone. So again, I said one of the most important things about this was the ability to work together with the people that were giving you the requirements, the people that were running the projects that needed estimates to give you budgets and maintain things, way to work with architects to understand how many services are going to be needed, how the information is shaped along the way, how you deploy, maintain, version, fix, all of these things. And the best analogy that I have for what event modeling ended up being today is it's a blueprint. And my constant, I guess, parallel in the industry is that it's more like engineering. Now you're working with a schematic to build something, right? Engineers have schematics that they work off of, some more solid requirements. Our industry looks kind of childish when we try to just say, we just do the next thing in the backlog, right? And we'll do a retrospective. Well, that ends up being a lot of rework. It's people blame cyclomatic complexity as why features take longer and longer to implement the larger the project goes. But it's really about the rework that we have to do as we find new requirements coming in from the backlog. We have more and more to revisit because our code base is growing as the project wears on. And as we get new requirements, we have to review more and more things that are incompatible with the new piece that we're adding. So there's this gross kind of hockey stick curve of complexity, which is not good. It's an exponential rise in costs of doing the next thing. It all looks good on paper. We'll just do this next small thing, but these small things end up being large, not because the thing you're trying to build is big, but the impact of adding it to a system that already exists is big. So you've heard in Agile the small design up front. Well, this is a way to do it properly. I don't think anyone really does any small design up front in Agile projects. It's just a word that they say to say, well, what are you going to do instead of big design up front from the waterfall days? We'll do small design up front. Well, what's your guidance? It's like, just make sure it's small. There's no guidance from Agile. Use UML or use whatever else you find. Like, who cares? Well, I care. UML was onerous. It actually came from, those use user stories. Well, user stories are kind of way too high level. They're not too close. They're not close enough to the implementation for me to use it as a real guide. So these things weren't really answered. And so by making this more of an engineering practice, what I mean is that we're working with a blueprint, but we can't make the blueprint UML. We don't need to have something that duplicates code one for one on a picture for business. That doesn't help anyone. The abstraction level is too low. UML is going to take way too long to draw, to use as a guideline and maintain. So we needed something that Greg kind of started doing by putting events on the timeline, but we needed it to do more. So how is that different now? Again, back to the analogy. So imagine we're building a house. We will have a table on the construction site, a large table where we will roll out a blueprint of the entire, an architectural diagram of everything. That diagram may have 1 or 2 pages which you can flip. It may have some overlays that are clear to indicate some notes from a particular electrician or a plumber. But we're looking at one blueprint, and every day we know how to build the foundation, where to pour the concrete. We can see where to put the walls. we can also see that this house will have 2 stories. So we know that these walls have to be supporting walls, right? In Agile, we have, hey, we're going to build the first floor, and you don't know next week you're going to be building a second floor. So in Agile, you build the walls that are not supporting walls. Well, next week I come to the construction site. Hey, guess what, everyone? We need a second floor. So what do you have to do now? You have to destroy those walls or reinforce those walls. In other words, you're adding work. You may have thought you were finished, but you might have to add reinforcements, or you might have to destroy a few of the walls and put them up again. That is the equivalent of what we do in the industry and software, which is still costing time. Say, well, software is not like other industries because there's no real costs. When you build a bridge, you can't just, find out that you made the angle wrong and destroy the bridge and try again at another angle. Yeah, that's a oversimplification. The reality is that it's time and materials. We have more time on our side than materials because we flip bits. We can easily npm import another library easily, but we still spent time, and it's the same cost as materials in a lot of sense. So the fact that we're destroying walls, it's also a time cost. So we have that parallel. If we have a blueprint, we know that further down the line we're going to have a second floor. So we're not going to be stupid and put in flimsy walls on the first floor. We're going to make them supporting walls, so we have a good foundation for the next pieces. And that's essentially what it is, what event modeling is. Now, if you haven't read the event modeling, the blog post, that's the one that I wrote in 2018, and it still holds to today. I do need to have some corrections in there because there are a few additions that I made, not too important, but it captured, what the essence was. I'm just going to share my screen here. Hopefully you can, this will go well. Share screen. All right, so this is the event modeling blog. And the original article here is 17-minute read. That's at the bottom. So we go to event modeling. It kind of gives you a short intro, which I'm not too happy with. This is the only thing that I'm really happy with is the original article. And it is the basis of the book that I'm writing, but it goes into kind of the motivation and it goes into the background, which I haven't gone into, that I usually go into, why event-driven systems are the weird thing, the odd way to do things. I start with, why we're in that situation. And really, there's a reason in the starting of computing that storage was something that was a big problem, and why computer systems didn't mirror how we worked as developers in automating them. So this is quite interesting about the fact that we couldn't store ledgers because it was too expensive, and that it changed everything. A few explanations here, but kind of the 7 steps to get one of these blueprints going, we break it down by steps that we'll be doing here. Although I want to try a different format for us. So in the way that I think about event modeling is really, yes, we do have some events that we talk about, such as user signed up for my website, or whatever that is. We can use, I try to use a yellow because when you do this in person, these are usually yellow stickies that are available more easily. And you're going to have a lot of events when you're using event modeling. So best to use the sticky note color that's mostly available. I know there's others that use orange for events, and even my documentation uses orange for events because that's a standard. But when doing this in practice, there's just way more white paper and yellow stickies available everywhere. So why not use those for the most common pieces? So events are, each event is on a yellow, and it marks something that happened, because we're going to be using this as a store of truth. So when we store the truth about a system, the facts of the system, they're always in past tense, because I signed up for the website. Now that's on the ledger. And I can keep adding events to my ledger and store that somewhere. If you're using modern tools, there'll be event store, which you can use for being able to quickly get substreams of these, so organize them into specific streams. So for example, this might be order 1, and then someone else opens up an order 2. We can put those in separate streams and understand that over time, this is what happened. So over time, actually I'll put the timeline above, this is what happened. But the important piece in event modeling is that organizing these in swim lanes for separating entities is fine. And we can do that by showing these entities as being divided into their own swim lanes by also making these dotted lines. So now you can copy this and put it here. And so that's, these are events for 3 different orders. If we have a store, we can show the progression of people adding things to the carts, to their orders for 3 things, if we're doing a website. But then if we have a separate system for tracking inventory of those items, we can, at this point, put in, oops, I actually don't want that. I want the solid line. You can start to change these and say that, hey, we have a payment system. So here we have maybe a order system. And I can put that like this. So that's the order subsystem. And here will be our payment subsystem, or maybe inventory system. And inventory. All right. So now we have, instead of a usual subsystem UML diagram where you have a two subsystems shown as order and then inventory. So out of UML and similar things, you would have that these two interact, and probably maybe show some arrows that both systems interact. That doesn't tell you much, right? We can even have some schemas in there, but it's not going to show you a set of actions that are happening, these events in both systems. The other thing that was missing, remember, I was trying to do more with less. So what else were we missing? We were missing the designs of what the UX UI is going to be like, what the web page is going to look like. And so if we're adding stuff to the cart, we need to show that we have some text boxes to fill out the quantity, to select, which product we want from a list in a search box. And we want a button to go ahead and do that. So we have some UI things that we need to add to show what's going on. So these user stories have to be replaced by what's going on. And so we also need, customer, right? We need a customer actor to say that, hey, this is what this person is doing on this timeline. This is what they're seeing. They don't care about what events get stored in the system underneath. Well, they do. They kind of do. It's in their mind. They registered or they put something in the shopping cart. When you go to a website and you go to Amazon and you put something in your shopping cart, you don't need to be reminded by Amazon that you wanted the, you know, the brush for your shower to scrub your back. You know that's what you needed, and it's what's in your shopping cart. But you need to kind of show that the system remembers that as well. So, you know, and if there's another actor, such as a delivery driver, right? Is going to be interacting with a different part of the system, you know, somewhere down the line where, you know, it affects the inventory, right? It's going to be taking some inventory out of the warehouse and putting it on a truck to deliver it to you. They'll have a different interface. I just shortcutting it here. So we have another swim lane for a different purpose. And in this case, it's separating an example. Now, these are always done with examples. So everything is done with, instead of customer, we would have, you know, something like Joe, the customer, and Mike, the delivery driver. And each event will have different things like added product to cart. And in there, it'll be item back shower brush with long handle. So, you know, that's one of my proudest purchases is a proper shower brush, so you can scrub your back. It's one of those things I realized didn't have for a long time, and they bought one recently. That's very good. It really makes you clean and gets your skin nice and fresh. So the interesting part about this is that, yes, we have a system now that does describe what we're going to store. We store these facts, but it's still a little bit too far from what's usable for implementation. What was that? Did not want that. Okay. I want to select these and move them above. So the question is, how do we show invariants and that we can or can't accept something? Because I can put something in my shopping cart and I can put 1,000 of these brushes. Well, that's probably gonna not pass my visa for purchase. It's probably gonna have a couple of other things that are gonna go wrong with that. Probably don't want to ship 1,000 of those brushes because the supplier can't supply you that many. You don't have that many on hand. So invariants are of one type are things that can get rejected. So if I do something stupid and ask for 1,000 brushes by mistake or on purpose, my intention is now marked with a command. And actually, I don't want it to be that bright. Let's try this light blue so you can see what we're writing. Add brushes to cart. Notice the difference. It's imperative. It says, I want to do this now. And if it's successful, I then store the fact that I did this, which is why this isn't past tense. But we can link the button to this command. And then if it passes, and in this example it does, we link it to this event. So I pressed a button, and that means this, you know, oops, sorry, I have these arrows going this way because it remembers what I did last time. Right? Does that make sense? Now I also want to see that now I have this, you know, items in my cart. One, and this is somewhere in the top here. And obviously, how does that web page display that? Well, they probably have some sort of a table that shows what's in your cart and maybe a summary. So that goes to the last concept here, which is a cart table. And it's a projection of the events. So we're going to make that green. And in there, it's going to have Joe has one brush in his cart. You know, structure the table as you want. It could be, it doesn't have to be a table. It can be an object in an object store. Really doesn't matter. Use the thing that works for you. But it subscribes to what's happening. So you can do a pub subsystem that immediately updates this. Or this can be strictly conceptual, where if I say, hey, this is Joe's page, I need to show what Joe has in his basket. So conceptually, this could just iterate over all events and make sense of what Joe has done before. That is event sourcing. So this could be a live report type of scenario where a subscription service somewhere in your infrastructure listens for all types of added product to cart, just updates this. That's more event sourcing than event modeling. What I'm trying to get across is that even though you may be doing a traditional system or an event sourced system, it doesn't matter. The events still convey what the system does. You can still follow this. And what I've done here is shown the first pattern, two set of patterns that we use to track our work and how we can start to estimate. If you draw this out and continue to draw what happens with the driver when it comes to delivery time, you'll notice that we have a reservation of all the fields that we need to take. We have a place for where all of the information about what's going on ends up in the different systems, in the different parts of the system. So the fact that all of these things are stored, we know that our system has integrity. When the power goes out, when we go back online, these events are sitting somewhere. If you're doing a traditional system, these events are not stored, but their effects are stored in things like tables. In event source system, it's the opposite. We have these that are stored, and we don't necessarily need to store things in a table. Although if you're doing CQRS, you're going to have projections and you're going to have a traditional architecture. That's usually what happens. But I've been experimenting more and more with just keeping the event streams, indexing them well, and then always reading from the actual store of events to show what's going on. And so the core concept that every system has, that is the pillar of event modeling, is understand how state changes and how state is shown. Right? So I know that with this button and this command and this event, that's one slice called I'm changing the state of the system. The system didn't actually know that I wanted to purchase something and put something in my shopping cart, but now it does. It stored this event. And the second thing is information, getting information out of the system. So this is input and output, but getting information system, the information of the system out to the user is done this way. It comes out. So you can see this as a water line. You know, you're diving underwater and coming back up. If you're following a web request, it's going through all the way to the back end, getting information or putting information in and coming back out to the user interface. It's a nice way to think about it. And other people have pointed out that this, in fact, is very nice because we get into a pattern of waves, meaning you do an action, you get a response from the action, a recording of it, you get informed about what's next. This could be a wizard or whatever, any other kind of interactions. And then the user has more information that they can now click the checkout button and continue on to the next piece. But we can just continue to string these along, and this wave pattern becomes quite apparent. And the wave pattern is made from input and output, or change state and view state. So in here, if we have a checkout button up here, I'm torturing myself with very tiny things. But if we have a checkout button up here, and I guess I'll have to duplicate it because the previous one has things here. then if I go to the checkout button, I can say checkout. And this might just change. You know, if everything's fine, then our event here is checked out and all the info about it, user Joe. Okay, you would use IDs, but in event modeling, I try not to mimic exactly what my implementation is. When a business person looks at an ID, it's going to be like, well, what is that? I never saw that on my web page. Maybe if I go to my account profile, I might in the corner have some sort of a clue what my ID is in the database. But in here, I generally replace IDs by emails or other unique identifiers, some other composite keys, so that everyone understands what's going on. I hope that makes sense. But that's the flow that we start with. Oops. You can group these to move them together. You can see this grouping here, group objects. You'll quickly get frustrated with Miro. I mean, it does a good job, but as you start to, make your screens, you're going to go back and forth. I added this checkout button here, but it was missing here. And this is my refactoring, right? In Agile, you would do this in code later, say, that page is missing this, or whatever. So here we can see already that our design is going to need, even though we haven't gotten to the checkout part yet, we got to it here. And so we know that we must affect the same screen here for the checkout. And that carries on through, more importantly, down below, because it starts to say that each system has a set of data points and schemas it must support. And knowing this up front saves you a lot of work. And this is why when we finish this entire thing, this is a proper event model with swim lanes for what different actors are doing, what happens in the system to store those, where we have validation, right? And then if there's, multiple ways that we can check out because there's different discounts based on different products being bought or different amounts being bought or frequency that you go shopping, you can start to do some given when thens on this. So if there's multiple ways to do a checkout, let's say maybe there's a field there that has a promotion code or something, or some other combination of inputs. Well, you can do this given when then. So given that you've entered some items into the shopping cart, I usually like these vertical instead. So let's say we added 6 products and we have a bonus for after you add 6 products of different sorts. If you've added these, notice that I'm no longer interested in, or let's say we can't add more than 6. We have a stupid rule. And then I try to add another one, obviously replace the data with real stuff. Then we're either allowed or not allowed. So in this case, we're not allowed. And so we're going to say, make this red. I'm going to say error, too many items. So that's one scenario. And the next scenario is that we add 1 less. So this should work. So we don't have an error, but we have the one that we wanted here. So now we have 2 scenarios that translate directly to unit tests that we can implement to make sure that our command handler is implemented correctly for adding another product. And this, of course, can continue for maybe 20 or so scenarios for different things. Now, there may be different ways that we show the cart or an invoice, and the same scenario works for this. So when we have a checkout, a checkout screen for showing the amounts that you're going to pay or whatever, you have the same idea. You might have added some things to the cart. But the last thing that you did after adding those things is click on checkout. So checked out. Yeah, I should be zooming in. But anyway, I know what I'm doing. So I checked out. And we want to show what the screen is going to show. So we steal that one. See how I'm just copying from what's up there? Then we'll see this. Notice that structure. Given these things, when I try to do this, then I get an error. Given this history, when I try to do this, then I succeed, and my success is marked by another event. That's all. These are excellent ways to talk about business rules and invariants, because they are functionally pure functions. They actually do not, they force a pure function mindset, meaning that all input needed to process this is shown here. There is no extra call you need to show for what's my exchange rate or anything like that. You assume that you have all the information given to you in the previous events. And that discipline allows for very clear implementations and specifications, and ones that business understands. When you show the business that you have these scenarios, and you can label them, right? You can label them saying too many, cart can only have 6 products. And obviously we could just add an extra line here, right? Cart can have only 6 products. We actually can label both of these. You can put a whole thing behind it here to group it, and we can link it to, this as being the expansion here. We're expanding that into these sets. And then this here, we can show, let's duplicate this for the size. Here, the scenarios may be, it's really not writing well. I'm still not awake. I've only drank a quarter of my tea. And it's gotten cold again. Oh well. We'll take a break shortly in about 5 minutes. We're going to have 2 breaks because it's 3 hours. So we're going to make them short, 5 minutes to get tea and whatever else you need. So in this case, for talking about this here, our example is going to be, oops. It's not this. We're going to have discounts based on items. And we can show, some, this is not a cart, but a checkout invoice summary. And in here, we can show a couple of scenarios, or more than that, where we have, fewer items here and something that's empty. We have you can also show the null case here if we want, where we didn't actually stick anything yet into our, right? So if we have 4 items, our summary can show, discount 5%. Discount if we have less. Discount 0%. We don't get anything. I should make these a little larger. Okay. See, people are clicking around already. Don't worry, you'll get your chance. I fixed it for you guys. All right. Now you're getting excited, but let me finish, and then we can you can participate too in a second. So we're going to be doing the same thing. But do you see now how we can start to get all of the scenarios that we want in something that people understand? You can take anyone through your happy path about what your system does and where the information goes, what information you take, and how you get to the check, how you get to a happy customer at the end, and maybe show some bad scenarios where you have an unhappy customer because the item is sold out. Anyway, here, I hope you can see that the details you can break out into reusing these as the source events for painting many scenarios to show the different ways that the information can change in these screens. But this is a guideline for your overall workflow. You can start to make different workflows for different parts of the system and start to organize this. But generally, this should be a really, really long timeline showing by example how the system is used, and then implementing them. So, this is the first pattern that we see where you go round and round. You can copy this, and we'll call this the one complete pattern here. I dragged in these guys by accident. Delete, and it's one of your building blocks is the interaction. It's two slices actually. We call slices pieces of the workflow. So we have one slice called the command handler, which is basically what we do for inputting and storing information, changing the state of the system. And we have slice number 2, which is what do we do with information to show it to the user. There's no change of state, but how do we present the state in different ways depending on what the user is interested in? So those are okay. So people are asking. Yes. So sorry, I just noticed people are asking questions. So please raise your hand or some other way so I understand if you're asking a question. But going back to the question is from Jakob. If I pronounced that correctly, please let me know. He talked about swim lanes to the group events that belong to entities. Speaking in DDD terms, would it be right to say swim lanes per aggregate and aggregate route? Yes. So exactly. So I try not to introduce the domain-driven design terms because I find business gets just more confused by having to learn more terminology. So I say, yes, you have one entity, the shopping cart for Joe, and then you have another entity, the shopping cart for Mary, or another customer if you want to show them. And yes, these could be thought of as organized by aggregates or aggregate routes in domain-driven design. For those that don't know what that is, it's a way of finding entities and transaction consistency boundaries, such as everything that happens to an order must be consistent. You can't have things that don't that don't play well together in there. So it's a transactional consistency boundary is kind of what you talked about in domain-driven design. But I find that I want to get the same goals as domain-driven design, but I don't want to have to sit down and teach the business all the domain-driven design things. I want the same outcome if they were doing domain-driven design, but I don't want to spend 2 months teaching them domain-driven design. So I say, this is a cart and all the same cart stuff belongs in the same swim lane. I'd rather say that one sentence than have them study domain-driven design for 2 months. And that's, again, going back to how do I get things done in enough time without belaboring everyone to get on to either learning domain-driven design or some other, onion architecture or other disciplines like user story mapping or anything else. I don't want people to need to study books and books before they get going. They need to have the goals of all those books satisfied right now without reading those books. This is where event modeling shines. We have all those good separations of concern, good focus on users and customer success. We have the user story mapping. We have the architectural separations of different systems. All of these things are. I made one mistake here. Let me just correct this. These have to be slightly higher because this actually is a separate swim lane. Because this delivery driver has this. And this is important because it shows that we have one swim lane in between the user screens and user workflows and the system underneath. That is the layer in between. This layer is how you mark where there's input and output in the system. So unless someone moved this as well, so this goes here. That separates them. There we go. That's much better. So instead of having this from an architectural perspective in one document, then having some user story cart must not have more than 6 items. And then you have as a user, blah, 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 right? We have these, we have all of these user stories that are sitting in some Jira tickets or wiki or whatever, right? What else can we have? Some UML diagrams. We have some designer documents, right? So some walkthroughs and mock-ups. Right? So now if we take a look at so we have that. We have this for the architects. We have this for the designers. Notice the silos of information, right? I'd have to go talk to product owners and PMs about this. I'd have to talk to designers about this and whatever they're using. I'd have to talk to the architects and some UML diagrams. These are all silos with brick walls between them, with no collaboration, really bad collaboration, if any. You represent all of this typical stuff you have in the industry with one blueprint. Your blueprint is this. This shows you everything you need to know. I just move this to the side. Notice that you can get all of this information that's really siloed, and it's kind of like their own kingdoms. They control the power and no access. You know, same thing, you know, let's throw in another one. Oops. Let's throw in another one where we can change this shape. Let's see if I can change the shape. All shapes. Aha, it's there. But notice if I change the shape to a database table, we have a DBA, right? So who are the overlords here? Architect. Architect is protecting their kingdom. Who's here? DBA is protecting their kingdom. What is going on? Sometimes Miro is doesn't get the focus and it starts doing its own thing. So here we have product owner. Here we have designer. Okay, these are all nasty silos because they have, let's put in a nice graphic here. Brick wall. Do we have a brick wall? Oh, yes, we do. I wonder if we can use that to make mini brick walls. Do these stack? Is this transparent? Yeah, sort of. I guess that'll work, huh? Some brick walls. Come on. It's awful. It's awful. There. That one's ugly too. There we go. Haha. Cool. So, okay, so we have a brick wall. You can group it. And then just copy it. And we can put these brick walls in here. All right, that gets the message across, right? Control V. There's a brick wall there.
I guess most of the people in here are aligned with your ideas.
I hope so. I think everyone is frustrated, right? I think everyone is frustrated in the industry. And this is why I did this, right? I wanted to find solutions for this. And I found it in making a reliable engineering-like way of working so that, you know, all the subjective bullcrap would go away. And if you can have something that can be used reliably, then yeah, I think we made an improvement in the industry, right? To get rid of these brick walls. These are awful. These are really, really bad. And the excuse is, well, that's what the tools we're used to. And so we can, as architects, we can be most efficient if we're only using UML. Well, yeah, but even if you're 10% less efficient using this, you're 5,000 more efficient about communicating what you want to the rest of the company. So is that a good trade-off? Yes or no?
Yeah, absolutely. So just a reference point, a small project I'm in right now. We're using Trello and Slack and email and SharePoint.
Yeah.
But the good thing is we're not so many people and we have a close contact with the business. But even though we have that, it's always like, yeah, but why doesn't this work? When I'm logged in as this type of user, why can't I do this? Well, if you check that Excel document in the SharePoint, it says you shouldn't.
Yeah, it's, you know, you will have the goal here, whether you're using event modeling or not, you can use other tools or not. The idea is to break down the silos, but also you can't break down the silos if you, as effectively, if you introduce things that have to teach too many things. Now, someone asked, does event modeling relate to event storming? Yes, there's high parallels with it, simply because it came out of the same set of people doing domain-driven design back in, you know, between 2003 to 2010, around that. I kind of started doing domain-driven design before doing event sourcing, but event sourcing really gave domain-driven design a way to go forward. Alberto and Von Vernon did event storming. We kind of used it for a little bit, but really it was the event given when thens that we were using here. This was the core of the start. These two scenarios was how event modeling started. Because events were used in event storming, we said, hey, we're kind of doing event storming. So we said that we're doing event storming. And in 2018, when I went to the summit from Alberto in Italy, in Bologna, they said, this is not event storming. I'm like, I thought we were doing event storming incredibly well because we're getting all the way to implementation right away and we're not stuck with a lot of half-implemented domain-driven design projects, which is what I was seeing. I was seeing a lot of incomplete domain-driven design projects in the industry, bar some exceptions like Jimmy Nielsen, who was able to effectively do event sourcing quite early on traditional Oracle databases and things like that. But most people were not having success. And so what did give us success is this. So for us, it does replace event storming, although there are some common things. So events are common. Green pieces here for showing read models or different projections of events, that's common. Blue is commands, that's in common as well, although these are orange in event model and the events are orange in event storming. We switched to yellow because there's just more sticky notes that are yellow that you can buy, as I said before. Event storming doesn't focus on user design, like the interface design and the workflow. They added like 3 more flavors, but it's really an afterthought. Their core, event storming's core contribution is the storming part, is the brainstorming at the beginning, you know, coming up with all the events that can happen in your system and then grouping them into areas of interest. It's more like, you know, word games. Are we using the ubiquitous language? Here we're allowing those problems to pop up. If I have some troublesome naming where my cart and order are interchangeable, I can plainly see that I have confusion when people are talking about those things. So I don't make it an explicit exercise to talk about the types of words used in the events, right? Whether we call this orders or we call them shopping carts or whatever. We allow that to happen naturally when we say, are you talking about order or shopping cart? So we go like, oh, right. We have some ambiguity here as to, you know, what happens to the checkout invoice. So this is supposed to be the invoice. Man, my writing's really bad. Need more caffeine. Okay, so you know, those things. It's a really good question because event storming got really popular because ThoughtWorks put them on their tech radar back in 2018, I think, the fall of 2018. The ThoughtWorks radar put in event storming as the only thing to adopt. Out of all the technologies and practices and whatever else they have on that tech radar, the only thing in the center bullseye to adopt was event storming. That gave, you know, this entire approach to event-driven systems quite a leg up, and people understood it quite well. But shortly after this, actually that was 2017, I think. Yeah, that was 2017. That was the ThoughtWorks one. So November 2017, that ThoughtWorks tech radar is the one where event storming got put in the center bullseye. But I wrote this in 2018, this approach, with the article that I showed you here. You know, all of this. I wrote this in 2018, published the website on the website. I think I had just an article on LinkedIn or something. Published it on the website, I think beginning of 2018. It took off that year. It ended up being on Hacker News because it kind of took what event modeling gave you, which is a collaborative part, but gave it teeth with saying, look, I need to do some of these. So, you know, some of these things, I need to know how they're implemented or where they're going to sit, how the sequence of events is going to actually happen, how to get proper estimates from this. Because now that we've done 150 projects doing it this way, I have really good metrics on what is the average cost to build a command handler? What's the average cost to build a read model? And associated pieces such as, you know, the screen that the UI, that the read model is going to populate. You know, the way the button and the input fields for the command work on that screen. So by slices, I mean exactly that. We start to look at, shoot, let's try this again. Yeah, we look at dividing up everything by these vertical slices. So as a developer, you can go and implement one of these vertical slices, like this, for example, you know, cart table and the wherever that's going to get displayed on the next screen. And you can actually attach it to that a little bit there. You can say that if I'm working on this slice, I know from the event model what the shape of the data is. And I have also some examples of how it's going to work with some detail here if I want. So I can start working on this part even before this part is done, because if someone that I'm working with is working on this command handler and the screen beforehand and the storage of the common event, we have a contract between one another, right? So when I'm finished and they're finished, it'll work just fine. That's your satisfaction criteria, is that all of this works together. And we've taken this a step further because we're so sure of these estimates that all projects we do are fixed cost. We basically say, if you do an event model with us, we will build, you know, if we charge $5 for each type of command handler and that, in this case, I have 1, 2, 3, 4, that's $20, please. And we'll guarantee that it works as long as your system is doing what the event model shows. If you want to change things, obviously you'll have versioning problems because you have more fields or something in your events. So you're going to have a version 2 that you're going to have to move to, and that's going to cost you, you know, new slices. But we can always work off of a blueprint, just like when you build a house. Like you need 4 walls, well, that's going to be twice as much cost as 2 walls. You know, you want to get into that aspect of estimating as well. So we've entirely thrown out anything agile in terms of t-shirt sizing and all of that. It's just gone from, you know, we're using the same, pretty much the same infrastructure code for each project. So there's no infrastructure really to code. All we're doing is making different UIs and different command handlers, different read models over and over again, right? So I got into the first pattern here, 2 patterns here, input and output. But then there's other things, like in your architecture, you're going to have one thing ending up in another, and you're going to have to call, one event ending up in another service, right? How do you do publish, subscribe? How do you do external calls to get information in or information out? There's a set of input-output systems here, and that's where we, you know, if you read the article, that's where we start to add the gear, which is a way to say, this is a robot doing this instead of a human. But all of these gears can be replaced by a screen for a human to do it. So you can turn any gear into Mechanical Turk, right? If I have a pub sub thing that wants to, you know, move one of the order events into an inventory event, like, for example, the event of, you know, checkout, the fact that someone has checked out. We want to, you know, find out what's in their cart and all that. We can say publish checkout. So things to check out. So first of all, let's just get this pattern over with because it's a really good one before we take a break. I kind of find it hard to stop when I get going. So here we will have, checkouts to publish. And this pattern is a to-do list. To-do list is the pattern that's going to save you so much confusion with talking with business. Use to-do lists. People understand what to-do lists are. I need to check out. I have a list of checkouts to do. And in here, I have the information I gather from, as well, this event. And if I want, I can cross-reference that here. So there's no problem with augmenting a processor to augment from other things. So if we have a table that already has that information, we can use it. But what it's going to do is it's going to create a command publish checkout, and in there is going to have Joe, and it's going to have brush. Joe has a brush that he wants to buy. That is the checkout, and this is something that could be done on a screen, but the important part is that this ends up in the inventory system. So what do we call this processor? This processor is called publisher. Oops, what the hell? Just doing that. Okay. Publisher. And what is it publishing? Well, it can be a generic one, but I like to call them specifically. So checkout publisher. And if we want to have a second service, such as, so we have inventory for deliveries. If we have another service that also is interested in this to make PubSub a little bit less trivial, you can add another swim lane. And in here we might have, well, let's just split up delivery, right? Since we already talked about delivery. So if we want this event to be published to the delivery system as well, we have that. But the important thing is publish checkout. We can have the same thing going to here, because these will change the data. So another important thing to note, when we have this, when architects talk about this, make a copy of this, and we have information between two systems being exchanged. Let's borrow something from domain-driven design called the anti-corruption layer, right? Because you don't want all the information from order to be in inventory. You know, you don't care who maybe got it, so you don't need to publish the name. So there's these concepts of anti-corruption layers that can live on both sides. You know, before the anti-corruption layer is done, before it leaves, right? Cleans up the data. And then also on the other side, it can also be cleaned up even further when it's received. So where does that happen on an event model, right? These anti-corruption layers, before things go out on the wire, when they come back in. It's broken out for you. The to-do list can leave things out already, meaning that, you know, you have, let's make a proper representation of this. Oops. It's not what I wanted. So if we have delivery, which also cares about this, we know that delivery might have other information it doesn't care about. So these command handlers are actually different if these anti-corruption layers are different. And this gives you a chance to name these. So publish, and you can say, in fact, you can just make it a subscription instead of a publishing, right? So you can say receive subscription. Of checkout, and here you might have, you know, just item. And checkout for inventory, right? So for inventory. And here we have receive subscription of checkout, and that would be for delivery. And that might have, let's just make these a little bit bigger. and this might have Joe and the address, right? Notice that it's done here, and here, this to-do list needs to have both. Needs to have Joe, brush, address, right? So it's quite clear as to what the publish side needs to have teed up and queued and ready to go before the subscriptors do that. Now, your implementation won't care. It might just push what's in here onto whatever service bus you're using, and the anti-corruption layer exists as at the boundary of these services in these swim lanes, where these command handlers are essentially allowing you to change the information so that the events in here only store what they need for their version of what happened, right? So this is another pattern that you're going to have. So we can copy these pieces. You're going to be using this a lot. Let me try to grab all of these. And the boundary. Okay, so that's messy, but I'll clean it up. So copy all those pieces. And the next major piece, and this will work for calling out to external services as well. Yeah, so let's clean. Oh, I forgot the gear. Oh, and I got this guy. Almost did it. I forgot the gear. Oh, please, come on. All right. So this pattern, first of all, shows pub sub between two services. So instead of just joining this to this, hey, this published from here to here, that doesn't tell enough. It doesn't tell you how information got changed over time and what was done. So you will use this over and over again. And if something gets published again and you have another, another event that gets put to another one, you just take all of this, and maybe without this. Take all of this, duplicate it. But this time you want to show that it goes somewhere else further. So you don't need this one, because now you're saying that, hey, this is the one that's going further, and it's put into another one, another service. Right, and so I can just keep copying and pasting this pattern and renaming everything. That's a nice crooked line. See that? So now you have your event models are kind of done, using this one. Well, let's duplicate this so we have our building blocks up here that we're going to use. This is all you need, these two sets. You can copy paste these everywhere to make your systems and just arrange them. But it's as easy as, right? That's all. I shouldn't have pressed that one more time. Ugh, I messed it up. But you get the picture. And you want that cadence in your development. You want people to be copy pasting all this stuff because that's predictable. I want to go see what the other developer did, right? And how they did it. And just adopt the event handlers for my purpose. See, I can just join them quickly like that. There. See, now it's all together. Easy. There you go. Now I made something here. I joined these again. I can continue with, actually, let's make them on the same line. So there you go. And then these can extend this. Get rid of this. Use this. Get rid of that. There you go. So copy paste these things. Now you'll notice that there's commercial tools that are being developed. Rafael in Poland is doing modulation. Bobby Calderwood from he was at Capital One for a long time. He's doing ONote, which allows you to do all this. And for example, if you make a screen or an event and you rename the event, it renames it everywhere. So Miro is just a whiteboard, which is the lowest common denominator that you can get for collaborating with everyone. It's used. It's quite yeah, it's used in the industry quite a lot now for collaborating. But if you use a whiteboard that's made for event modeling, you're going to go even further faster. So any questions? Oh, we do have questions. Yeah, larger system. I can show you a larger system. Yeah, it looks nice for such a small system. So the system that I'm working on right now is a US-wide implementation of an insurance company, which has a lot of business rules. We have about 1,200 of these workflow steps to the point where Miro is breaking. So this scales well. Yeah, modulation. If you go to the resources, so another tool, so I'm building up this tools area. So if you go to the website and up to the top and go to resources, I updated this. We have some videos, but yeah, it's in beta, modulation. And I don't know why this screenshot is not working. I have to fix that. I'm sorry. But modulation is here. So something happened with but if you Google for modulation, oh, here it is. So you can click on it. Nope, that's just a link to it. Where is it? Anyway, the pull request didn't work, I guess. But if you Google for modulation, that's another one that does code generation. ONote now does code generation as well. I'll be doing another workshop for that specific tool next week on the 10th with Bobby. So if you're interested, do sign up. I'm going to put that in here on this page as well. So I'm going to start using this resources page more. People have been asking, although a lot of times we're in our Slack channel. So if you go to the join Slack, we usually talk about these things there. And if people have questions, they ask me there. And if there's an event or explanation of tools, you know, both Rafael from Modulation and ONote, Bobby from ONote and Cache, they're in that Slack group available to answer questions too. So, and I'm going to try and keep these workshops, you know, up to date because more people are asking right now for workshops. We really didn't do many workshops since last year's giant one in November, which was a week long with many guests. It was more of a conference, but anyway. So hopefully that you start with event modeling practice inside an organization. So the easiest way to get going with event modeling in your organization, most organizations already have Miro. So just rearrange any information that they have and start to consolidate it into such a blueprint. This does scale. After the break, I guess we're just going to have one break since we're already at 8:44. Let's take a 10-minute break. And I'll show you a real life version of what it is to actually work with an event model as the only thing to guide your project. Because we do only that. We replaced everything with event modeling. Stand-ups, retrospectives, design documents, you name it. Every single thing now, even progress, like we start to mark up, you know, people will put in a little note, you know, Adam Dymitruk, AD, done. Maybe a little bit smaller, right? So it's green, and I can do the same thing in progress and do yellow in this checkout part is in progress.
Sorry
But it's
to
Adam.
interrupt you.
Hey?
Adam, sorry to interrupt you. You know, you can switch the type to a like a item card. So if you just select your
This?
and then the first one. And in that one, you can assign people, and you can assign labels, and you can set.
Oh, is that new?
I don't know, and you can set a date with the calendar.
Ooh, this must be new.
The only thing I don't like it is that when you write things here, you can't write too much because then you won't see it until you open the card.
Yeah.
But you can add detailed descriptions.
So I'll show you something else after the break, and it's a tool that it's a project that Mazen from Iran has done, and these things down here. Notice this. This statistics I don't have. If I put in a workflow, let me just show you before we go on the break. Man, it's going to take forever to get on this break.
Yeah. I need the break.
I know. Let me just see if I can show you one more thing, because Miro is extensible, so you can write extensions. Oh, what am I doing? Come on, let's try this again. Okay, so let's do this as a transparent and put this here, and then I can do workflow. What's it gonna do? Workflow test. Yeah, and then I have to show you on the other board, because I've basically added a little thing here that shows you if you start to organize your event model to have workflows labeled here, it'll pick up which ones are done and not done, and you'll have a list of slices and pieces that are going to take all this kind of information and put it here. And what Mazen's done is that if you click on an event, it gives you a nice layout of all the information, such as assignee and all that in here. So yeah, it's interesting. But yeah, thank you for this. I didn't know they added this. Before it was just sticky notes and shapes. Now it has this little thing that they added. But yeah,
and if you expand it, you can see there's more details in it.
Yeah, I will have to play with it. I haven't seen it yet, but we can play with that as we get to it. But yeah, lots of tools, lots of stuff happening for event modeling, and yeah, exciting stuff. So let's take a 5-10 minute break, and I'll come back and show you the real example, and we'll do some. I'm not sure if we're going to have time to do actual coding, but I'll get you started on a simple way of coding some stuff right in the browser, so we don't have to have your IDE up, and we can start from there and maybe do that as a homework before tomorrow, before tomorrow's whole conference. So 5 to 10 minutes. Go ahead and refresh your drinks, go to the bathroom, whatever you need to do, and I'll see you in 5 to 10 minutes. Okay. So for those that are back, so Steve, let's see who else is here that wants questions answered. I guess I'll answer some questions while people are coming back from a break. Let's make sure that the person that asked the question is actually here. How do you model long-running processes, sagas? Aha, we don't have sagas. I don't actually believe that sagas are supposed to be done. They're encapsulated in to-do lists or a series of to-do lists. We sometimes talk about an entire workflow process. If you think something should have state that this long-running process is working, it's simply a read model for progress. So you can have basically a line item in or a set of line items in some table or tables that show the progress of something. But I don't make workflows or long-term workflows a thing. I think it's a mistake. It's only added confusion and problems in projects. Long-running workflows like sagas should be avoided. The thing you should be talking about is sections of your information system. In other words, I already started doing this.
So just a comment to that. Mm-hmm. When you say you don't model it, do you mean in here or in general? I mean, if
in
you
general,
have some...
we don't even implement them as entities in.
Okay, so if you have something that requires 5 things to happen over a longer time,
they're read model.
Do you always make that like an aggregate to collect whatever happens and then react?
Not even an aggregate. Not even an aggregate. Because an aggregate tells that it's the authority on what happens, but in workflows, there's multiple authorities on what happens, really. And so what I do generally is if I have something that has 5 steps in it, like booking a trip, let's say you need to book the hotel, you need to book the flight, you need to book the car, and all of these things. There may be 4 things that happen in that saga, right? I wouldn't model it like that. I would have a read model that says these things are done. And once all 5 are done, then your trip is a success. It's a projection of things that happened. Individual state changes are done via these to-do lists. So I think one of the biggest problems with enterprise architecture is this idea of middleware, workflow processors, sagas, and long-running tasks that actually don't help. If you just track what information you need and maybe call something like overall booking, I'll do this here because let's just change the state, Yeah,
I guess I understand what you mean, because normally I use actor frameworks to I really like to work with actor frameworks, and
they're nice. I don't use an actor framework. You can use actor frameworks. They may help you if you're used to it to talk about your code. But if you talk about an actor framework to a business person,
so I was just coming to that when what you're saying, and I'm just talking out loud to myself and to you, that when you're saying this, really like a projection of a read model that my actor reacts to. So it sort of collects the events and stores it into its state, and then when the state is fulfilled, it does whatever.
Yep, exactly. So these things can be cron jobs that look at this every 5 minutes when the select statement comes back with something because the where clause is satisfied that all things are checked. Then it can produce one of these. Now the flip side of these, one thing I didn't get to yet, which we can finish, is that how does this to-do list get marked off? There's an implicit thing that happens on the other side that marks it as having been published, because these things actually get marked as done in here. Mark as complete. Try again. There we go. And this doesn't need to be so big. And the fact that it happened checks this as line item being done in this to-do list, so that this doesn't pick it up next time it looks. That's a good way of thinking about it. Your implementation may be reactive and does this automatically, but it's important to understand this mentality, because you can explain this to a person in any part of the organization. In any of these silos, they can understand this. As a technical person implementing this, you may have this done implicitly with some reactive framework, actor framework, whatever you're doing, doesn't matter. If you have something that really helps you, you'll get your slices done faster. It's just going to affect your velocity. But for the understanding of where the information is going, that's what you're going to do. So, long-running process, that's a big one. I have a whole video on why sagas don't exist, if you want to watch it. It's on YouTube. And so I get into that topic. Because if you think of the source of truth as just being a set of events and the fact that they happen in different services, ultimately you're tracking that giant thing in a giant process in one projection of what's going on with subscriptions from, you know, each of the different things in all the different areas, right? You can't actually do this. You can't subscribe from different services to one thing, because that implies a lot, and we already went into why. But the end result is that things that happen in a saga end up in some sort of a summary of what's going on. This is your saga. It's just a projection of what happened, and a whole bunch of intermediate steps that may have been taken in each individual service. So if I delete that, this is the reason that you need a publisher to do that publishing part. This is also something that gets brushed under the rug in systems design. You say, oh, it's PubSub. We have PubSub. This event goes from this service to this other service. Easy, right? Not so much. What happens to the information on the wire? Is it encrypted? Do you publish all information or just some, right? Does each subscriber take all the information from what's been published, or does it, you know, whittle down to the information to what it needs? The answer is possibly yes, both, right? You clean up the information a little bit before you publish it, but you also clean it up a little bit on the subscription side on each part. Some of them might be no ops. Sure, just take it all or just publish it all. But it's important to understand that, you know, these little areas, these places that filter and transform the information before it goes away to another service, that they're shown on a timeline and, you know, why they happen. And this is all I do for large workflows. I have a big rectangular area like this that says we're working on trip booking. There may be a read model that shows the overall progress. And of course, that overall progress, you know, if I use the example of my trip booking, so you might have a little checkbox in the top right as the saga plays out over even multiple days, because you might have to wait for availability of a specific car you want on your trip or a specific flight. Who knows, right? It's a full service for your vacation booking. You might have that interaction done via updates to your email or notifications to your app if you have it installed. But that can all be shown here in terms of the interaction with that long-running workflow. So yeah, always break up sagas into what it actually is that you're doing. If you want to organize it, put a big rectangle about it, you know, and say this is what happens in this long-running workflow, and be explicit about what the information, what's happening to the information on a timeline, so people understand that your trip booking needs 5 things: an airplane, a hotel room, a car, whatever, and some events, I guess, to go take the kids to, right? So all of that is explainable in this type of layout. So before we start on some exercises, any other questions? We had some typed in.
Yep, Adam. I have a question, and it's about long-running processes, or not long-running process, but process manager in accounting, right?
Mm-hmm.
I have a situation when you don't want for people to withdraw money from the accounts that they don't have.
Mm-hmm.
If you process a lot of requests in parallel,
Mm-hmm.
it basically requires a single point of processing.
Yep.
At least in current shape.
That's right.
How we are doing it.
Mm-hmm.
Are there any other options without the process manager?
Yes and no. So let's just review what happens. A lot of people want to withdraw money. So what you're looking at is this part of the workflow happening too much. How do you stop this from being done in parallel so you're not overdrawn? So you do that with a reservation system. You don't need a process manager, but because, well, in implementation, you don't need a process manager. You show on an event model that there is a reservation system. The only way you can do it is to do a 2-phase commit and an event-driven system that's shown by having 2 steps. So, you know, you would have to have this changed to a reserved. Then you have a processor. So 2-phase commit is represented here anyway, because you have a point of consensus that you need. What is the amount left in the account? Can I take this amount out? And how do I ensure no one else takes out money in parallel? You do that by serializing this. And one of the easiest ways to serialize it with is through a read model, because this will have the reservations, and it'll act as a to-do list, which will be done in a sequence. So once it does the first one and the second one comes in, the balance in the projection here will be wrong, and it'll refuse to do it. So that's basically how you model it. So you go back to, you know, I'm going to rename these because they're not actually using the proper terminology, but I want to show you the structure first. Okay. The structure is always a 2-phase commit type. The actual withdrawal is the second event. So you always have 2 events in that scenario, at least in terms of how you model it. Reserve, actually debit. This is your pattern. The fact that this can be done when you're doing your implementation, this pattern, the zigzag, can be done in one web request. There's nothing saying that this has to have a separate processor running or anything like that. But in terms of how the information gets coordinated, this is what's done. If this is in memory, that's fine. You have to make sure that it's using the common in-memory representation. So you're going to have to funnel that. This is about federating things, so people from one account can be on one server. You know, those types of things. Those are now implementation details. If your system is so, if your system is so intensely looking at this type of thing, let's say a good example of where this really matters is something like ticket sales for concerts. They go on sale at 10 a.m. on Saturday, and everyone on their website is going, I want the front row seat. Same problem as the account withdrawal issue. And that's always solved with a reservation pattern, a two-step thing. You can also pre-calculate some of these allocations, especially with seat assignments. You can say that some of the web requests go to this set of servers, right? You might have 100 servers spun up for when that concert goes online. And you might have a hash thing that, based on people's phone numbers, routes them to a specific server. Now you've reduced the problem to not have concurrency for all the seats from all the people that want to go. You have each set of seats assigned to a set of servers, and then based on some randomization of the hashes of the phone numbers or emails, they go to a specific server, and that's what they get. Because 1,000 people are going to be wanting the same seat. So at the same exact second. Do you understand?
Yeah, I think I got the pattern.
Yeah.
I will just try to play with it later.
Yeah, so I mean, if it's something that's not that important, like there's no intentional reason why people will be doing things at the same time, like a unique email for your registration process. There's an easy way to just not bother with checking, because it happens in a very, very odd time. And if maybe you had two browser tabs open because you had connectivity issues and you tried to register at the same time from 2 seconds, you can actually ignore the second part and make your system resilient to the fact that you may end up with two things being done in parallel from 2 different tabs. Right, so if you have 2 different tabs open, you can show that example like this. And obviously, this is not the cart example, but I'm just trying to show that it's doing things at the same time. Because what you're talking about is concurrency, eventual consistency, and all those things. And this one gets ignored. It also gets subscribed to, but because an entry already exists, it depends on your implementation. You say last wins or first wins. It's up to you. You can update the table, but next time you go log in, it's going to be whichever one succeeded on this side. And if they have to reset their password, they have to. Who cares? It's going to happen once in 10 million times. So why code for it if the risk is not big for them to just re-register? There's bigger issues that will pop up with the system than this.
The most interesting situation is when people would like to exploit the system for profit.
Yeah, well, in that case, if there's a huge vulnerability, then you do move to the 2-phase, and then you remove the vulnerability.
So essentially, we are serializing 2 legs of 2 commit in 2 events. Yeah,
serialize the access to, and it's really up to you to implement what is the, the mutex of that, if you will.
Interesting.
Yeah.
Are there more details about that on your why sagas don't exist talk, or?
Yeah, I mean, this comes up all the time. So, I mean, I talk about it at least once a month in depth on all the meetups and everything. This is a very, very common thing. If you look at any CQRS discussions on forums all the way back from 2009, you will see, how do I ensure, the classic question is, how do I ensure that someone else with the same email doesn't register at the same time as me? Because by the time I go around and display this, it's someone else has gone in and changed it. A lot of that goes away with just having this entire chain going from here to here to here to here, in one web request. And the return web request gives you the next screen. So if you have a next screen here, all of this part of the workflow is one web request. Going from here to here, including everything underneath, is one web request. And then to show the next web request, you duplicate the screen, maybe you add some more and repeat the process. And that's the simplest thing that could work, that has no eventual consistency issues. You can actually, look at the table and add the invariants to the table itself if your projection is in a table, and have it all in line, all is synchronous code, all or nothing implicit rollback. So that's a common pattern that I use to get rid of the complications when people start to look at this type of architecture, event-driven architecture, go to CQRS and start to really worry about eventual consistency. Then remove all the async stuff, make it synchronous. It'll still have the source of truth as events, which is the most important thing, and you'll get rid of your concurrency issues. So that's what I would concentrate on. So we have about 20 people left, I think. Let's do an exercise where I will divide up the group into 4 subgroups down here. And so I'll make 4 groups, and we're going to make 4 exercises. Feel free to zoom in so that you can maybe move all this stuff above here. Oops, how did that get left out? Try that again. Why is that one not there? Interesting. Keep leaving one out. Okay, I'm highlighting everything. What the heck? What's going on with that guy? It's probably locked. Someone pressed the lock button on it. Or someone has it highlighted. Any of this highlighted? Why did that go? So yeah, see, so there's some interesting problems with Miro. It's just a mystery. Aha. Long press to unlock. So someone locked that. Sometimes you can lock objects, and that's what happens. Why we need better tooling. We always need better tooling. So the first assignment is going to be, I did this already in a workshop before, no, in a meetup, not the workshop. So I want you to reverse engineer Uber or Lyft. If you were to restart that project, use the current system, you need to do that. The next one is going to be easier. I'm going to have a time tracking system. Pretend you are running your own consultancy and you have consultants. They have to report time. You have to bill your clients. The next one is going to be, we are going to be doing a, what's an easy one? Point of sale system for a grocery store. So you're going to have to do event discovery of the events. And the last one, any suggestions for something you want to do? What would be a good exercise? From the audience, suggestions from the audience.
Tickets?
Ticket booking is very exciting. Yes, ticket purchase. Online ticket purchasing. Now the interesting thing is that event modeling works quite well for manual processes. If you think of events as forms people fill out or actual things that happen in a business, you can do a non-automated manual set of instructions for how to run a business, how to operate a farm with no computers, by showing the different workflows and different criterias of what's supposed to happen in a system that's not automated at all. This is what makes it really good for people from the business side to get into a good collaborative kind of mindset with everyone that's working on that. So let's do this exercise for about 15 minutes. I want you to take a shortcut. Usually we take, we start with the 7 steps, we brainstorm all the different events. I want you to just copy paste these little blueprints. See how I duplicated them? I want you to do that. Concentrate on the users, the swim lanes for the users. Concentrate on the swim lanes for how many different subsystems you're going to have, and paste a whole bunch of this stuff in and organize it to fit something like this to describe this. This is an express workshop. You have to do this fast. So I'm going to divide up everyone, and you're going to have to discuss quickly what is in scope, what's out of scope. But it really would help to think about these systems from the user perspective. What do they want to see on the screens as they go through? And that'll allow you to fill out everything else. So now I will divide everyone up into 4 groups. Oh, someone's already copying. Well done. All right. But who knows if you're going to be on that team. So I'm going to make these. Where is it? I have to stop sharing, I think. And then I can make the different rooms, breakout rooms. There it is. Okay. Breakout rooms 1, 2, 3, 4. Let's participant choose room. Do I do it randomly or do I let you choose?
Random
I know some people are hoping I want the thing that I wanted. But what's that? I'm sorry, I didn't hear. Go ahead.
Oh, sorry. Make it random. It's quicker.
Make it random? All right. Assign automatically 4 breakout rooms, and I will name them to be Uber, time, point of sale, or ticket. Yeah, there we go. So now I will rename the first one to be Uber. Second one will be time tracking. And third one will be rename, that'll be point of sale, grocery store. Okay. And then the last one is online ticket purchasing. Okay, you have 15 minutes to finish. Open all rooms. People are slowly coming out of their breakout rooms. Henny, nice to see you. Good to see you here.
Thank you. Yeah, I was looking forward to the next workshop.
Yeah, there'll be lots more. I got some awesome stuff coming up. So this is, are you going to the main conference tomorrow?
No,
Okay.
I came just for the event modeling. How things are with your book?
They're moving. They're slow, but I'm in the middle of a giant project, so it's trying to find time is pretty challenging. But looks like people are slowly getting out of their rooms. So I should probably just get rid of the rooms now. Okay, the breakout room thing is still showing people as being in the rooms, which is very strange. Okay. Oh, not started. Okay, maybe I'll just close it. So I think everyone is back. So hopefully you got a chance to see. Let me quickly review how we did. I'll share my screen.
It's one of those unfinished projects.
Oh, of course. Yeah, I don't expect you to write a full system in 15 minutes. But I hope it gets going. So customer cashier, scan tomato price, cucumber. Okay, we got the patterns going well into that. Checkout initialized, scanned items, discount added, payment started, prices calculated. Okay, so we have a payment confirmed publisher. That's great. So we can do that. And yeah, we could have gone further into this with getting a automation, a processor calling out to a payment provider for Visa, right? That's another swim lane. You could have added, you know, a Visa processor, right? So credit card processor, or credit card payment, I guess. I don't want to use the word processor, it's overused. So we could add another one here and have the little gears do that, you know, copy something from my example there for doing that. Oh, sorry, I started the grocery store. Okay, I'll go back up to start from the original one. But this is good. This is a great start. Start to, yeah, maybe look at the examples for calling out to an external service for payment would be a good exercise in this one to look at that. It's good we have forward motion. One of the reasons I wanted you to copy my example here is to make sure that you always see the arrows going forward. It's kind of like Git history. This is your accounting of what happened. So there's no backwards arrows pointing. You reuse screens, you reuse read models, you reuse events to show more and more of the scenarios. Just change the data in them to show different scenarios. All right, Uber. It's weird how this always on different computers doesn't, you know, show properly. Dispatcher, rides. What else do we have? So we have rides and we have drivers. Okay, so we have two subsystems. That's great. Dispatch central, confirm ride, right? So some of this information that you have here, you might want to put into a second read model. That's my suggestion here, but this is really good. Arrow pointing the other way, but that's just a cosmetic thing. Right, this issues the command, ride confirmed, driver accepted. So looks good. So I like the fact that we have at least the fields. When I do these, I try to give an example data as much as possible. So I try to have something that will show the specification by example. Remember, event modeling is really a very big extension of specification by example, where specification by example or behavior-driven development is all about providing examples to follow. Humans love examples to follow. That's why it's an effective communication mechanism, right? So in here, we would have the fields. We would even fill out the fields with some example data for that to be fully thought out. But this is great. We have two subsystems. We have a processor that's a dispatcher, and it makes sense. And yeah, we got lots of other screens that you didn't get to because there's not enough time to do this. That's wonderful. Time tracking. Let's take a look. Time tracking, report, submit the report. Yeah, details. This is really good. Approval system. That's wonderful. Yeah. Project registered, approved, user assigned to project, issue created, issue assigned. Okay, this is great for even issues that might happen. So good. I'd like to see more. You know, I guess there wasn't enough time, but some of these events end up getting glued together a little bit more. So you know, where does here we have project registration, assignment, employee assignment. So we have projects, but where do the employees come from? Is there a read model for the employees? You can trace this back, obviously, to people registering for that and walking an event model backwards, asking, where does this come from? Where does this come from? Will continue to give you the motivation to keep specifying things to the logical start. And if you take that to an extreme, you can even make your project installer or setup scripts with all the default values that you need. So this is really good. I like the form of this. You got order delivery down here, but I think for tracking, we probably would want to have real world things such as the boss writing a check to everyone, right? You can have those events in here too. Someone in another group was asking about, do we put real events like in the grocery store? Can we put real events in there, like someone actually getting paid by a check or someone leaving the grocery store or entering the aisle, the checkout aisle? Yes, you can. I sometimes put those events in the swim lane right at the top to give context. Or I can even put a picture of someone walking into a store or in this case, a car arriving. I can put that in here as a picture for the Uber example, right? But this is good. Any questions from this team about what issues you ran into? But it seems pretty straightforward.
No questions from my side.
Excellent job. Excellent job. So I think compared to other workshops that I've done, I think I'm going to continue to provide the building blocks. You know, a lot of times just let people freeform, add their own events, add their own screens, add their own commands, add their own read models and all of that. And I think it goes a lot slower. So I think I'm going to just continue to have this basic structure to copy paste and start with people, you know, focusing on the user workflow, what the user wants, what the screens are that they should see, and work backwards from that. I think it's making this workshop go a lot faster. Online ticket purchase. Sorry, what's that?
I think that's a good idea.
Yeah, it's you know, too much time is spent wrestling with Miro, I think. So this shows a little bit more of that. So okay, what do we have? Online purchasing UI. Okay, great. We have all of this, all these concepts here. Confirmed payment. Yeah. In this one, I'm looking for that way. I see some processors. So ticket purchasing has that problem of people trying to buy the same thing all at once. Let's see if this got answered here. Push to Joe address. Ah, you did not. Okay, well,
so this is just the example.
Okay, well, this looks good. This is your copy of mine. So Okay, so I see you're working with this. You just copied this as an example to look at. This is your work here. Entered waiting room, entered payment. Yeah, sales confirmed. Show available seats. Yeah, so select seats. So yeah, that's the next part really, to get a good understanding of this. Thinking about one of the things of the ticket problem is I usually have two swim lanes for two users competing for the same thing. So you can stagger this kind of workflow through here. And so you have Joe and Mary trying to get front row tickets for the same concert in the same day. And that's going to make you work through the example of how you treat information so that you have no inconsistencies, so that users get the example. You know, usually you have, you know, something that happens on a ticket thing is that you have, you know, the front row seat, five seats in on row number one. You have 5 minutes to complete payment, or it's made available again, right? You have those types of screens in those situations. So I'd expect those screens to be shown here. You have 5 minutes, and then you can probably show another user expiring their 5 minutes and that reservation being canceled. Sometimes it's just an effective time on a read model, and the processors are able to filter out things that are more than 5 minutes old and show them again. You know, lots of ways to do this, but that's the next steps. I hope it made you more comfortable with just copying, pasting these workflow steps, because this is our bread and butter. Our entire company is really based on copy pasting these patterns, right? I complicated this one here, unfortunately. But you know, it's really just keep working by adding these. Every unique event, every unique command handler and every unique read model is an anchor for effort, for how large the system is going to be. That's how we do our billing. It ends up being very much copy paste. Now we're over time slightly. I wanted to quickly go into an exercise here to do that. So one of the easiest ways to store events is in Indexeddb. If you look at this, I'm going to paste this URL. You can fork this project very easily. You don't even have to sign in. So I'll paste that up here into where did we have our information? We had a little information sticky somewhere. Where did it go? Yeah, we had all the, oh, there it is. Here we go. This is our information sticky, very small. Make it bigger so people can see it. I'll put it here in the middle. And at the bottom, this is the URL for the code. Okay, and it should take you to here, which is a simple click to run, add a book, event modeling book. Okay, and it's going to cost $39.99. And we have that. We can add another book. Event sourcing how to, and that's going to cost $12.99. Okay, so simple book list item, but you can repurpose this to be the to-do example, the Uber example. All you need to do now here on the code is add things such as retrieve events, and actually I should probably have slashes, not on was doing some bash stuff yesterday, so doing a different.
Adam,
Yes.
could you post it in the Zoom chat instead?
Sure.
The node is highlighted in Miro, so you can't follow the link.
Oh, no, you know what it is? Good thing you mentioned it, because it's still, if someone has it selected, it'll, here, what I'll do is I'll also comment on it. If you go to my comment, you can click it there too, but I will also post it here. I keep forgetting that, yeah, when everyone's looking at the event model, it does that. So here we go. It should be in multiple places now. Sorry about that. Okay, so so we need a way to store an event in Indexeddb. Now I'm using Indexeddb because it's something that doesn't require you to really deploy anything in the back end. It's all in the browser. So you don't even need an IDE to do this. You need to retrieve events, right? You need to store projection / object or object for a view. What other things do we need? When we look at our event model, what do we need to do? Here you have the basic moving parts for being able to store information in a database that's behind the scenes. You can have multiple types of keys that you can do. Let me just see if I can duplicate this. I gotta get rid of this stuff that's in the way. Duplicate tab. That's right, so that's there. And if I go back, can't go back. Let's close the panel. Boy, where did I go? Maybe here. Okay, here we go. So if you go to search for Indexeddb, you'll get to the JavaScript info on here, /Indexeddb. I'll post this as well. Because this is the fastest way to try out event sourcing if you want, or even without events, but get an example going incredibly quickly with just straight HTML with just some JavaScript storing that, which you can then later expand to a real project. So I'm starting to do more of my examples in Indexeddb because it's much easier than having to have all the participants have the same IDE and, you know, maybe a specific language like Go or whatever. JavaScript is everywhere. It's a fact of life, like taxes. You know, everyone pays taxes. Everyone must know how JavaScript works to a certain extent. But you can, you know, the nice thing about event modeling is that you can take that as pseudocode to implement what you would want on the back end in Go, in .NET, in Java, and whatever your background is, whatever your, you know, some people were already saying they're using frameworks for actor models. When no problem, you can you know, adopt that to an actor model, or if you want, you can add more, you know, more scripts here just to try different things if you're happy with JavaScript. But this should be a way for you to persist your event store that you build for either the Uber example or whatever one you were with working on to do this. So I definitely want you to think about what happens at the end of every arrow in your examples, right? That we are storing an event. We're storing an event here. Here we're issuing a command that can fail. We need to check that against previous things that have happened. We need to look at the previous events. Here we're subscribing to some information. Do we have a way to grab that event as it's being stored? After it's stored, can we listen for that event? How do we show that information? How do we also how do we also work off of that as a to-do list? So does that make sense, that every single endpoint on these arrows is a to-do list, like a task for you to do? After I press a button, something in the system is done to store that event. Something in between has to say if it's okay to do that. Did I put in some invalid values here? Right? Can I implement a set of tests? Can I just add a button here to run tests, or just add some more functions to add tests? Can I include a test framework for JavaScript in here in my includes and start to write that? But honestly, this is all you really need. Yes, yeah, Jakob, go ahead. I see a raised hand from Jakob. Ed, did you have a question? Audio not working. Okay, yeah. So if you type something, yeah, no problem. Yeah, let's leave this for questions and answers now. I don't think we can go more than 10 minutes. We start about 10 minutes late. I can stick around for people that want to play with the code and do other things. I was going to try and do some collaborative coding using some other tools. If you have your favorite tools for collaborative coding, let me know. The JetBrains stuff works somewhat, but it requires people to have those IDEs. Again, a little bit too much of a burden for participants to use. So if you have your favorite collaborative coding tools, let me know what you like, and maybe I'll adopt one of them. Meanwhile, while we're waiting, any other questions? For what we did here, given wins. Oh yeah, the larger board, right, I forgot. Okay, 1 second, let me pull that up. Yes, absolutely. There is a generic pattern that you have, or some multiple, but a few amount. Yeah, the estimates are easier to do because you're copying the same code going from each command handler to each event handler. You're doing the same thing over and over again. Evgeny, nice to see you. Take care. See you next time. And of course, for those that can't stay, the Slack channel, you can join that community. I'm usually on there answering questions among many others. So on the resources page of event modeling, there is a join link for that Slack group. And if you have questions, I'll definitely be able to follow up there. So yeah, I use event modeling for all my documentation. So let me just unshare this so I can get to sharing the larger example. But yeah, I only use event modeling now. There's nothing else that I add. But the reason for that, I don't want to have people switch between different styles and different repositories of information. if you scatter the information, again, that blueprint mindset is, the blueprint mindset is incredibly powerful because you're forced to look at the schematic of the reality. And the minute you need to hop around to get information is where your cognitive load increases, not just for you, but for everyone else in the project. And this is multiplicative. You continue to have to add more time to consolidate those pieces of documentation so that they're in concert. So you want to keep everything on a single page for as long as possible, because that requires the least amount of jumping around, and people are in agreement and have a cohesive understanding for the longer time. And yeah, it's a challenge to scale, and I'll show you right now where that is. Well, so I do have, I have to break them up into 2 or 3 when they become really big because of Miro's complexity. In fact, I'm loading one up. It's taking a long time to load. But I'll show you a large system right now. It's taking a long time to load. So let me see, maybe that's not the right one. One more second here and I'll show you the other one. Yeah, once you get into really large event models, Miro just doesn't scale as well. This is why the other tools are badly needed for not just this, but anything that allows you to collaborate and consolidate information into one. They need to scale much, much better. Okay, it's not responding. I'll show you one part of it, I guess.
Quick question.
Yes.
The ONode, is it possible to import stuff from Miro or?
Yeah, I'm working on that add-in actually. That's on my plate because what I'm doing is that little add-in that I showed you on the left. That actually is it's something that interrogates the Miro board, and it can export all of the core pieces and where they are and whether they're events, whether they're commands, whether they're screens, and then transform it to a common event model document type, which can then be imported by any tool. That's one of the goals, is to have this. Okay, so I found the, let me see if I can zoom out on this. Okay, so this is just a small portion of the system. Share screen now. All right, so as you can see, there it gets quite large. This is one of 4 boards for this project. There's about 1,200 workflow steps. The project is probably $1.5 million worth of development, so quite a lot. But yeah, the approach does scale. Some of the tooling is improving, but what we're doing is essentially making sure everything's explicitly on there. So this is a large insurance company. The different rows of things that you see here are different workflows for underwriting, approval, insurance cancellation, the billing aspect, so prorating insurance. If you have to cancel your insurance halfway through, there's obviously, you get a refund for the amounts that you're not needing coverage. All those workflows are here. You can see some red and green workflows here. So, you know, we have one workflow labeled here, another, you know, workflow labeled there. All the screens, sorry, all the swim lanes show where the different services, where the information comes from along those areas. But yeah, this gets incredibly large. You can see the comments are kind of hotspots where people are asking, a lot of questions about certain things. You can tag people in it. So you can see most people are working in those areas on the left at this time. We generally clear and read those comments as they get finished. So it becomes, this is where the collaboration happens, and it happens, quite well. Again, this is one of 4 boards of this size. Each one has around 250 to 300 workflow steps explained by example. So that's that.
Question, Adam?
Yes.
How do you work with when you develop this? How do you create like cards or items for things to do?
Yeah, so I can show you. We basically mark them as what is the workflow? Sorry, well, what is the statement of work? So which area, which component? So here we have CMS, we have agent, we have consumer front end as big areas of the system in terms of workflows. This is part of the agent workflows. It's the non-renewal workflow. Tim is working on it and he's finished.
Okay.
And that's basically how we track that. And this little tool here that I have on the side, this one interrogates this and it reads these things. Although I'm getting rid of this because I'm making sure that those large rectangles tell me what the workflow is. And then of course there's other ways in Miro now to assign things to, as we saw, but it's just doing this little add-in is just interrogating the Miro board to see what rectangles are in what other rectangles, and based on the text in them, say that, oh, this is a status report because as the word done, it has a percentage and it has this and it's inside something that's a command. So I know that that command is done. So there's a lot of ways to automate reporting off of this, and you can also schedule it. So, we scheduled the efforts to be around certain workflows, finish this workflow first, and then this one, and then do demos on it. So we use the event model to kind of make a backlog of what we're going to work on next and what's done. So it's no point to have the individual command handlers in the backlog as items. It's better to have a more coarse-grained one. We can also see how many steps there are, so we know that this is 3 times as big as this one. It's going to cost 3 times as much, and we basically use this as a way to say, how much of the project is finished. What's the estimated cost for everything? Because we have we have all the command handlers written out and all the read models written out. So then we just multiply it by our average effort for those, and that's the cost to the project. We also have velocities for how many command handlers and read models we can do per week, depending on how many people we have working at the same time. So we can also give a timeline estimate for delivering the project. And so that's a real life project that's quite big. It's the largest one in terms of budget and complexity that I've ever done, and it would have been impossible without event modeling, not for the amount that we wrote. This is an entire insurance company from basically almost zero functionality. There's one component, one service that does the pricing for insurance that we call out to. That's an off-the-shelf product. But all the CMS, all of the accounting, all of the renewal notices for people that are insured, those are all done from scratch. Then an entire system that's used by multiple agencies across multiple states is all done from from the ground up. And without event modeling, we wouldn't be finished in 6 months. This is a 2-year project by traditional standards with way more people involved, but we're able to cut a lot of that complexity out by not having to iterate in an agile way and redo a lot of these things. They tried, actually, I think these guys tried event storming before, but they never got that next step as to how to implement it. And so we actually did reuse some of the events from their event storming, but then continued with the screens and flushed out the rest of the details in these event models. And then we got a more accurate estimate for, the size of this project. But yeah, that's the largest one I've ever worked on, and they're just getting larger. Bigger banks and bigger institutions are using it, but at the same time, we're using it with simple startups that just need a simple app to do something. They still also use an event model to show, those initial MVP projects as well. So yeah, it's worked well. But I hope that gives you, the relief that this is not something that stops working once the projects are not trivial. It's something that actually is built out of addressing the scalability problems with communication and all that, right? All of this was born from the hardship of growing projects from small to big, and that's why it exists. But that was
congratulations.
Yeah. Yeah, it's this is entirely unplanned for. I didn't think in my career I would need event modeling. We ended up with the only thing that could work in these high stress situations as kind of cornering the important concepts. And if you get those core concepts right, your state transitions are explicit, and you're explicit about state views and where you get that. You understand how the system is coupled at all times. Those are going to be the pillars that make sure you avoid all the mistakes and all the inefficiencies of redoing work unnecessarily, which just burns time, pushes dates out, and why software is so difficult at times. And so hopefully this is another tool in your tool belt to be able to communicate with people very quickly. Event models can be done very, I start, if I'm on have a paper napkin and I'm at lunch with someone, I will draw some screens and I'll draw some events underneath as to, okay, we need to store these things. Here are the screens that people are going to see. That napkin can be the start of a full event model. And it doesn't need a computer, doesn't need anything. You can just draw that on a napkin really quickly with a friend that's working with you, or you're talking to someone that wants to start a business, and you get into an interesting conversation. Just start drawing. Like, what if we showed this to the user and then show them this? How are we going to get from this screen to this screen? Well, we probably need some processors here. We need to transform this kind of stuff and make the computers do this for us. It makes it really easy for those conversations then to start what you're going to actually do. That's what I like about it. The fact that it's iterative and allows you to expand. It allows you to focus on the core pieces. You understand that, yeah, these systems will need a sign-in screen. You'll need that, but you don't need to be distracted by it. You can dive right in. Hopefully the Uber example and others showed you that you can just plunk in those core screens in the middle of what's important in your application and work outwards in terms of what's going to happen in the subsequent workflow steps, what has to have happened beforehand in terms of signing up and configuring the software, all those details as well. Work backwards from those important concepts. But yeah, I'm happy to stay on for longer. I know we're over by half an hour, but if you have time, I have time for you. So let me know. You're free to drop off. I will redistribute the recording of this, so don't feel like you're gonna miss out on anything if you have to go and others are still talking.
Cool. I can just take an example of the project I'm in right now. I did present the event modeling, and I also had the, we can call him product owner or project manager. It's a small team. I had him read on your blog also, and he started about the same time as me a year ago in this project, and it was fairly developed already. So I presented this and I said that this is how we can do a blueprint. We can get all the knowledge here. It's like, yeah, it's a good idea, but you know, then we have to pay for Miro board, and we have so many other things to pay for. We have to think of budget, etc. And it's like,
yeah,
not really a cost on it. And then he said, well, in the next project, because they want to build 2 more systems. He said, in the next project, we're going to do it for real, and then we can use that one. But still, we have not super complex system, but it's complicated. And it's really hard to understand what things do in the system and things like that. So how do you convince someone that you should really have this? It's going to cost you a little bit, but
yeah, it's you know, we're working on experience papers for, you know, people that say, I already do agile, so I have 0 time for what you're proposing. So we just want, you know, tickets to be written and organized in the backlog. The experience papers show that the time that you burn organizing the you know, the backlog, whether it's backlog grooming, all of those activities, you end up spending the same amount of time anyway. You might as well just do an event model, because at that point you have gained so much more in terms of communicating all the different concerns for a project, instead of making it a priority battle for, like, do we put the button in first, or do we do, you know, some infrastructure concern here? And I think it's really important that that time is now organized, really well organized, between infrastructure and actual functionality. You know, the traditional stuff tends to bundle any item that's technical together with others. So make the website faster, but also add a way to add favorites for your product. Those are very different ways to do, you know, to be at a computer and type things. They accomplish incredibly different goals. And so I think with an experience paper explaining that your efforts that you're putting in are not just, you know, tags, Jira tickets tagged differently. You're visually showing that the work you have to do is not going to give you something that the user can directly see, right? And so it's a lot of the problems with treating software as one giant bag of to-do items that are, you know, prioritized, is that those nuances are lost. And I think the wrong feedback is sent. It looks like you're doing nothing because you're working on the back end, and I'm, you know, pixel pushing every day, and everyone's really happy with me. You have a harder problem that no one can appreciate when you solve it. I think this gives the transparency so that people understand that, hey, this actually affects, you know, 50% of our workflows, where there are indirect consequences with delays and other things that you can talk about. So I think the conversations that happen around an event modeling board are a lot different than when you're talking about, you know, what are my blockers today? As a good transition, you could probably have an event model that you have to have when you're doing your stand-ups, instead of just having people talk about whatever their blockers are. Those are subjective, and I think a lot of times used as a you know, a social exercise to appease people that you're doing work and, you know, keeping up with everyone else. Again, Scrum and all that stuff comes from war room emergency state of workflow. If you read the original Agile books, it's a state of, you know, being in an emergency situation. Scrums and war rooms are done for, there's no time for planning. We need to get things done as fast as possible. To have that for an entire year is a way to die of stress. You can't be running on adrenaline for the entire year. That's not a good workflow. We need to plan and estimate properly, and then execute and do these in different, cycles of time. Some may be a day, some may be a week, some may be half a year, and it's okay. It's not, everything needs to be a 3-week iteration. No, that's artificial. That's not true. If you talk about the system and understand what it does and how many pieces are moving and what information moves across, you can make the decisions about when you want to release, how often you want to release in general. You have a lot more clarity into what parts you want to demonstrate first, what needs to be built first. Not just a random, well, not random, but a very ad hoc set of tasks with really dubious estimates around it. All our estimates come from actual work, which is great. And because we have these 4, I went back at the beginning, it was just these 4 patterns, right? The 4 patterns, because you're only ever employing 4 patterns, you get a really high sample number of your efforts across multiple efforts of work. And so now when you do an event model and say, hey, that has 10 command handlers and it has, this many read models, you're like, that's going to take 2 weeks for this team. You can almost immediately say that, right? But you have to do the work to make the event model. Not that you can come up with a magic number really fast. You have to actually do the work and show what information is, how the information is used, what information you need, when it's available, how often it gets transformed. That's what you need for an estimate, not like, oh, this looks hard. What kind of estimate is that? Like, this looks complex to do. It's like, really? We're not writing new, I sound like a broken record, but we're not solving computer science problems. We're not making a new search algorithm. We're moving data from left to right. We're transforming data from this version to this version. We're filtering data. There's like 4 core operations we do over and over again. When we're automating a point of sale system or an inventory system or an insurance company, it's the same thing over and over again. And we tend to want to complicate it again. We have an enterprise patterns book with 50 patterns of like, really? No. Saga? No, thank you. I don't need any of that. It's these same things over and over again. It's boring, and it should be boring, like Torvald says, because boring is predictable. That's where you're going to get the budget that you need to do the work so that you can do the exciting stuff, spend some time on making the UI look nicer, or other things that are more interesting, rather than this, answering at a stand-up with a gun to your head. How'd you do yesterday?
Yeah, I totally get it. I've been I've been saying for many years that estimates is just a waste of time, because if it needs to be done, we have to do it.
Yeah.
And of course, in some projects, you might want to have something done before another thing, but anyhow.
Yeah. Yeah, it's estimates is a big problem. But if you get common patterns being done, lots of times you can use the real work measurements, which is really good.
Exactly.
Regarding those patterns, can you now hear me? I'm trying.
I can hear you now. Yeah.
Yeah. Cool. Regarding those patterns, are you aware of any library that collects or something like has a mapping of those event model patterns, the errors and the model elements, to real code blueprints in certain stacks? Because I assume people will
we do it manually. We have so when we do an event model, we're copying code from previous projects because it's exactly the same.
But what would be interesting, I think, is when I'm starting out and I want to have the Java Spring Boot stack, how do we translate things to something like that? So a collection of how do I build an event model with Spring Boot and Axon Server would be interesting, or how do I build with .NET and
That's
EventDB?
what ONote does. So that's what ONote does. That's what modulation does. Mohsen's framework does the test stuff. So it interrogates the Miro board and auto-generates for you all the test scripts for the given when-thens and other things like this.
Okay.
So there's a lot, I never liked case tools because they were always UML, make, you know, a graphical representation of a class, and then that's going to generate code. It was bad. In this case, what we have is we have information flow, which is actually a proper sourcing of what could be interpreted as code. So, you know, it took 20 years to get here, but, you know, when we were looking at the rational unified process back in 2000 and some of those case tools for basically, I make my class diagrams and I'm going to hit, you know, code generate. It's going to give me interface definitions for all that, but it's very superfluous. It doesn't capture, at least not well, the behavior of the system. In this case, behavior is baked in because we have a timeline. For an event model is based on a timeline. So you have so many examples. And if you have more and more examples, you'll know from artificial intelligence, the computer learns, right? You can interpret these patterns, and, you know, fast forward another 10 years, there'll be enough people that have written functional code that you can just reverse engineer what the event model has and grab from GitHub all of the code that most likely will make those transitions. If there's a cadence to how we do this, which is why I think event modeling is the step to do that. It's really about event sourcing, but it can be applied to things without event sourcing. But the concept of state transition, because that's what event modeling concentrates on, you can then have these explicit pre and post conditions at every single step in the event model to then match code that does such a thing. And so that's what's going to be way better for generating code. And you're absolutely right. ONote and all those things can be plugged in with a template for what your framework needs for setup of any of these, and just click a button. And as long as you made the event model, you should have something that handles that type of event, or handles that command, or even has a rudimentary UI, if you dare go that far. You know, those are things you can do.
Boring again.
Yeah.
Yeah.
It's, you know, things are, I like, you know, where HTML and CSS is going with HTML6 and all those good things. The paradigms for dragging rectangles for what should be shown, it's not that far off from what you can auto-generate out of rectangles these days. It's not too far off. So, and even if you have just the structure, semantic, like logical structure of what those are, you can always custom CSS place things, and you can have designers do that, but you know that the system workflow as to what they click, what happens next, is already solid. That's, you know, information flow in my mind is the best backbone for any architecture or anything you do technically. Those are really important things to make sure don't change, and therefore it forms a really good backbone for that. And if you have it done with predictable patterns, not just like, oh, information's changing this weird way, I don't have a pattern for that. I think you do. It's finding the Lego block. It's the right size, and I think we have it. I think the UML Lego blocks were too small, and I think some of the you know, some of the stuff from Agile was Duplo blocks. They're just too large. They're for babies. Bad hand-eye coordination, so you need large blocks. Now we have the good. We have the good nice Lego blocks now. Yeah. Yeah. But it's you know, it's something that I'm happy with, because it allowed me to talk with more people in organizations so that they understand what's going on. That transparency, people give, a lot of times I feel people give lip service to transparency. We try to do it in Agile by talking a lot, but that's one it's removed. It's kind of hearsay. This is my opinion of how things are. Whereas with an event model, this is how things are. There's like, you know, I can tell you the same thing, but you can see at all times, this is where things are at right now. And so that's where I think it really does a good job to remove subjectivity out of the exercise of building software, so that you're always looking at the reality of how it works, which parts have been finished, which haven't, who's worked on those parts, and there's really nothing to hide behind. It's so transparent that I think a lot of times people feel threatened by it. because their career was based on, you know, how they handled themselves socially within an organization. And there's many stories of people that are smooth talkers that are getting the promotions, end up being managers to, you know, over the people that actually did all the work and just were introverts, right? So I think it's nice to have something that's less subjective to base work on. It's more fair. You know, I mean, we don't really have interviews. That's the nice thing, is because we ended up moving to this, you know, fixed cost way of working. Everyone that makes a command handler gets paid a fixed price, and everything associated with, not just the command handler, but, you know, that UI above it and the fact that the event is stored below it. Same thing for the read model. All of those are paid out exactly the same. And so we have a junior person working, you know, they're going to be slow. They're going to be doing 4 of those a month. And the fast folks are going to be doing, you know, 10 of those a week. People that have been around for decades, they're incredibly fast. And the pay is auto adjusted. So if you level up as a junior person and all of a sudden you're doing, you know, 4 a week, you're going to get an automatic pay raise because, you know, you're just getting more done. And of course, people can't just quickly do it because we guarantee everything for free. So if you've added your slices too fast and there's errors, you're going to have to stop, fix them before you get new slices. So
yeah.
So it's the right carrots and sticks. It's very, it's not subjective. At least where it is subjective, it's a more collaborative process of saying, hey, we need to get these done. Can you help me with this? I'll give you these slices. And people are really much more empowered to organize the work to be efficient, because everyone gains if you're more efficient. It's another thing. It's not really competition. It's about having a team that can get more done together. So I've seen more of the game theory play out in the projects, because there's no hidden agendas. Everyone knows that they've marked these things as the next ones that they're going to be working on. They know who they're going to have to talk to make sure that the pieces click together. And so it becomes really, really good for really enabling the people doing the work to not need oversight, and allow them to be as productive as they can, to work when they want to, spend extra hours if they want to, or take a day off if they want to. The velocity of what they're getting done, how much they're getting paid, is all transparent, which is really good. Yeah, I don't want to go back to the old way.
Sounds like a cool model, and a fair thing.
Yeah, it's really good. I hope that tomorrow during the conference, you can map what you saw here to some of the things like the event sourcing methodologies or patterns and other technical aspects, because I think you can represent all of them. Again, it's tech agnostic, so you should be able to, you know, map what you have in your event model to anything you see tomorrow. And if you see things that you like tomorrow in the conference, you can make that mapping, like what you're trying to do with Axon and other frameworks. You can easily map that. How do I get from seeing this screen to seeing this screen? And does my system capture that information which I showed it capturing? Pretty simple, but explicit and relatable. So yeah. All right. Any other questions? Oh, everyone's joining the Slack. Yeah.
Yeah. Sorry. Quick question. That
Sure.
plugin you were showing in Miro, Mulzims, where can we find that?
Oh, I was gonna post that, and I think he posted it in the Slack. Let me just double check for you while we're here.
Okay. And just to follow up, do you use Jira? I mean,
we have to, because some clients are just, it's all over the place in their work. It's how they work with other providers as well. So sometimes there's links in the event model to a Jira ticket, because, you know, if it's for example, if there's a bug and you need to make a bug in Jira, that's fine. Ticket trackers are built for tracking bugs anyway, primarily. We only adopted that to plan work because of Agile, I think.
All right.
But yeah, you certainly can interface with other systems, and you have to, depending on that. If you're lucky enough to have a startup where everyone's learning everything for the first time and they want to improve, then you're lucky. You don't have to adopt any of those. You just keep working off the event model, and the longer you can do that, the better. Okay. Because you're going to have one thing to manage instead of many. Well, let me just see. Yeah, I'll post it in the chat right now. I found it. Brilliant. He has a video on it in there too, which is wonderful. It's called scenario hunting. So it hunts out scenarios out of your event models. Copy link, and you know what? I'll even add it to. No, not here. I'm on the wrong one. Here, it's in the chat. So that's scenario hunting. And yeah, you can see a video on it, and I'm going to be using more of that for building Miro tooling. I think also because Miro is used everywhere, I can't just tell people to use ONote or modulation or anything else. That will be yet another thing they have to buy or learn or whatever. So you know, adding this little button into Miro is a real easy way to get people to start thinking more in this, and then naturally say, hey, you know, Miro is not performing that well. Our event model got really large. Is there a way that I can move this to something that's built for event modeling? The answer should be yes. And so my goal is to give those transitions and to basically make a standard notation for the abstraction of an event model, just like you have any other type of document standard. That's not too onerous. It's lightweight, doesn't have opinions about data like Protobufs does and other things, right? Protobufs is this, ended up being this kludge of band-aids after a while, because they're trying to, you know, expand its use, and by expanding its use, it had to be used with different stacks, which had different languages, which had different opinions and types and collections and all sorts of things. And so now when you look at Protobufs, it's like it works in the most places it can work, but that's not a good thing, because it's a, you know, it's such a giant kludge of weird reasons why something's valid in Protobuf and why it isn't. And so I don't want that to happen to event modeling. A lot of people want to have schema stuff. I know that there's schema stuff coming out of ONote because a lot of enterprise places want, you know, want to do that, but they don't. But they don't see that it doesn't carry to other stacks. It's kind of a selfish thing. Hey, I'm doing this framework all the time and I'm based on Java, so I'll just naturally have some of these types. And someone that's coming in from JavaScript and Node, or coming in from Clojure or something else, Ruby, their types don't match up, and they're going to be like, yeah, that's upsetting. Why is the event model define these types this way? I don't want to go down that route. So before anything official gets released, we're still having kind of talks about where if that's going to happen. But eventually it will be. I want to have an export button here and an import in ONote, and just carry on with your work. If the tool that you're using allows you to collaborate with multiple people online, that's great. If it's something you're doing just by yourself, maybe an open source project that just has the documentation done in event modeling, it's in some sort of a format that's sitting there besides the README file that shows you what's going on.
That's great. Thank you. Thank you so much. Brilliant, brilliant workshop.
Andreas, thank you for joining. Thank you. I think I actually do have a meeting at 11, so I'm gonna have to go. But we did an extra hour, so bonus.
Thanks a lot.
And I hope, yeah, I hope you got the enough information and some homework to do. Implement those things. They're not hard. Just follow the arrows, write the code if you want to do it, and then join us on Slack for more reviews. And then, yeah, different next week workshop is on ONote, so keep a lookout on Twitter and other places as we announce it. So I got to get caught up in all the new features in ONote myself to be able to present next week with Bobby. So they got new stuff in there, and I got to find some time, which is hard to do these days with all these projects, and get myself up to speed and show the new features and see how it goes. All right. Well, I guess I will have to sign off now, and see you on Slack, see you on Twitter, see you in LinkedIn, and anywhere else that you know me from. Thanks again for coming. I will send out the recording, so if anyone's missed any parts, you can catch up later.
Thank you.
Have a great day. Bye everyone.
Have a great day.
Bye.